Welcome student to the lecture series of machine learning videos. So we will slowly take we will take topic by topic, and it would be a great learning experience for you. Now before we can start discussing the learning paradigm of machine learning, I would like to just put a disclaimer that the contents of the slide, the graphics and the material has been taken from books and various internet resources. So the only purpose of making this video is for the education purpose. So I have not exclusively cited the references, but if your content is present over here, so kindly excuse me, because it is only for the students, okay, to discuss. So whatever I found the best, I have brought it over here. So we'll start with the learning paradigm in machine learning. So the basic word paradigms means the various approaches, various methods which are there in machine learning. Okay. So first we see that there are 4 kinds of learning, and in principle we started with 3 kinds of learning. So one is supervised learning, other is unsupervised learning, third one is reinforcement learning, and semi-supervised learning. So we start with the first 3. The first 3 are actually mentioned exclusively in the textbooks, the 3 techniques, and the 4th one have been recently coming up, mostly available on the websites and other in deep learning books it is present. So we will be discussing the 4th one also. Now to start with, what is a learning paradigm? It states a particular pattern on which someone learns. So basically how you learn and what are the patterns on which you learn are known as learning paradigm. How a machine learns when some data is given to it, okay, its pattern of approach for some particular data. So that means if you are giving some data to the machine is actually learning from it. Okay, it may be following some pattern, so that approach is actually discussed. Okay, so this is totally data driven. So there are basically 3 types of learning paradigms widely associated with machine learning, namely supervised, unsupervised and reinforcement. This is basically a hybrid mixture of supervised and unsupervised learning. So we will discuss this separately, and that is why 3 is mentioned, because these 3 are actually present in your textbooks. Okay. So let's consider this label diagram. So if you take the innermost triangle, that is learning, and around which we have 3 kinds of learning. The first one is supervised learning. To start with, you can imagine that supervised learning has a labeled data, okay, and it has direct feedback mechanism, predict the outcomes or the future, whereas unsupervised learning has no label, no feedback, and finds the hidden structure, it finds the patterns. So unsupervised learning works on the basis of finding similarities among the data. Now reinforcement learning is used for decision making processes. It is a reward, penalty and reward based system. If the system behaves as per the need, so we reward the system. If system does not behave as per the requirement, we actually penalize the system. And the entire learning of an agent in reinforcement learning learns through the series of actions. Okay. Now we will discuss the supervised learning in bit more detail, and then we'll take 2 examples from supervised learning. There are many more examples from supervised learning, but over here we will be only considering two examples. The first one is supervised learning. Supervised learning is a machine learning task in which the function maps the input to the output data using provided input-output pairs. So basically in the data set we have an input and we also have an output. This output is labeled. Labeled means some expert or some knowledge source have actually correctly made an output classified. For example, if you consider a set of database which have the picture of dog and cats. So when the picture appears, so some expert will identify that picture and will make annotation like cat. So when we make annotations like cat, so this is becomes a labeled data. Whereas in unsupervised learning, there is no expert available, no teacher available, you can say. So there is no labeled data. That is a key difference. So the basic thing is that you see the pattern of points having green circles, square, black and red triangles. So these data, okay, are fed to the algorithm. So that means we have an input, remember, and we have also an output. Now this algorithm will be trained on, since we have a supervisor, which have already labeled the data. So this algorithm trains on the input set and processes the data. Then you see in output it classifies into 3 pairs, 3 groups like red dots, green and black. So that means we have segmented the problem, the given set, into 3 different types. This is supervised learning. Okay. So in this type of learning, both input and output, usually in the form of labels, are provided to machine to learn from it. So what machine does, it generates a function. That means it creates a mapping. If this input is there, so and this output is desired, so it learns from that and exactly creates its own mapping. So what machine does is that it generates a function based on the data, which can be anything like simple line or a complex convex function depending upon data provided. So this function over here is a simple line. That means y equals to mx plus c. Okay, so that is a function, and that is the algorithm learns that functions, or you can say calculates that function. This is the most basic type of learning paradigm, and the most algorithms we learn today are based upon this type of learning pattern. Because since now we in this age we are generating a large amount of data, we have huge processing power and a huge memory. Memory is cheaply available nowadays. So that means the focus is more on supervised learning. Okay. So this is very popular and common these days. So let's say 2 types of learning examples. One is simple linear regression. You see that the red dots are the data points, and we have to plot a line. The blue is a line which have a equation like y equals to mx plus c, and it passes through these points, okay, and the amount of error is the residuals, that is the distance from that line to the data point. So these are what? These are the errors. The green ones are the errors, okay. So and the equation is y equals to mx plus c, because that is one of the simplest form of expressing an equation of a straight line. So that equation is actually the algorithm learns. So this is a simple regression type. Regression means that we can predict if input x is given, so we can predict y, because we know this equation of line. However, in the given picture, there would be some amount of error which we can actually have to tell the user that we have learned from your input set and we are getting this amount of error. Okay. The next one is, in this series, is logistic regression. So the linear regression is used for predicting continuous values, and whereas logistic regression, when you require that the decision should be made between yes and no. Okay, suppose that you want to eat a piece of a cake, your answer may be yes and no. There is no third state. Okay, so are you going to watch this movie? The answer may be yes and no. So whenever we have a binary state, okay, where the user can take only one type of value, so that means we can apply logistic regression. Okay, so that means the logistic is a classification algorithm. Okay, it's a type of a classification algorithm where we have to select yes or no, or simply 1 and 0. So we see that we have given 3 samples to the algorithm. Okay, and we have some weights also, and then we have to predict whether I am happy or sad. So there are only 2 outcomes. So in this situation we can have logistic regression. Okay. Okay, supervised learning. So as we know that supervised learning can be used for 2 kinds of tasks. One is classification and another is regression. So machine is trained to classify something into some class. Okay, for example, whether the patient has disease or not. Okay, whether email is spam or not. So this type of task is what? Classification task. Where regression task is to predict something. So that means we have to predict some value like price, weight or height. For example, you give you predict the house or property price on the basis various inputs like location, number of bedrooms, okay, and the builder, okay, it is a 3 BHK or 2 BHK. So these are the input features, and that on those input feature we have to predict the property price, or you can predict the stock market price. So this is what we are doing regression. Prediction means regression, and classification means to actually find whether it belongs to some class or not. Okay, so with this help we are doing unsupervised learning. So unsupervised learning. So machine is provided with just input, there is no output. That means there is no expert, there is no labeled data. Okay, to develop, and the machine has to develop the learning pattern. Basically it learns from no results. So we see we have been given the same input data having green, yellow, green, red and black dots. There is an interpretation, unknown output, no training data set. And then the algorithm works on the input data, processes and segments these into 3 classes. The class 1 is triangle of red, circle of green and square of black. So it is segmented into 3 classes. So this is unsupervised learning. Remember, there is no labeled data. Okay. So with the input data, the machine has to find a pattern to learn. Okay. That means the machine learns through observation and finds the structures in data. This is still very unexplored field, because as I told, the world is now mostly focusing on supervised learning techniques. The big tech giants like Google, Microsoft are currently researching on its development. So we have 2 kinds of tasks over here. The first is clustering and the second one is association. So clustering problem is where you want to discover the inherent groups. Okay, such that you can classify the customer behavior, you can do the profiling of students or the customers. Okay, so clustering means you have to create a group based on similarities. Okay, and association rule learning problem is where you discover that and describe the large portion of data, such as buy X also tend to buy Y. So this is an association. Suppose you are doing an online shopping, and on the online shopping you are purchasing an item X. So a recommendation system will also suggest you that the people who have purchased this X item had also purchased Y. So you actually generate some sales into the mind of the visitor, and visitor most oftenly select Y also. And the association rule finding algorithm is a priori algorithm, mostly used in finding baskets of big departmental store. Suppose you buy bread, then it will recommend the butter. You buy the butter, it will recommend eggs. You buy eggs, then it will recommend milk, because all are the actually essential things for a breakfast. So that kind of thing is actually done over here in association. Okay. Now reinforcement learning. So in reinforcement learning, we have an environment and we have an agent. Agent performs certain actions. Okay. So actions are performed by the agent, and then through that action there is some change in environment, and that observation and the reward or the penalty is given to the agent. So if agent is given a reward, the agent learns that this action is correct. It may, in due course of time, may accumulate a lot of actions, and then it will choose the best according to the given situation. And if that action is actually bad, then the agent is penalized. It is punished. So if it is punished, so it is discouraged. We will discourage the agent to take the same action in that situation. So this is how reinforcement learning. The basic idea of reinforcement learning is that you can take, if you have a dog or a pup and you want to train it, so you throw a ball. If he goes and picks, you just pat him or you just curl him, and so the dog knows that, okay, with my action my trainer is happy. And if it doesn't do that, or he goes there and picks some other object, so then you slap him, okay, you pat him with some force. So the dog comes to know that I did something wrong, and the wrong is that I picked the wrong object. So he'll go there, keep that thing, and bring back the desired item. So this is basically a reinforcement learning. Okay. So there is an excellent analogy to explain this type of learning paradigm, like training a dog, as I told in the example. So whenever the dog responds correctly, the trainer gives reward to the dog, which may be a bone or a biscuit. And a variety of different problems can be solved using reinforcement learning. Okay, so more complex and hard problems are solved by the reinforcement learning. Okay, because a reinforcement agent can learn without expert or supervisor, the type of problems are best suited for complex problems. Okay, they appear to be no obvious or easy, or for the problems for which there is no easy programming solution. Okay, for example, game playing. In game playing, we use a lot of reinforcement learning. So determining the best move to make in a game playing often depends on the number of different factors. Hence, the number of possible states can exist in a particular game is usually very large. For example, consider the game of chess. Game of chess has a huge solution space. Okay, so in that solution space, it is next to impossible to make a program, which will consider the move of the opponent and suggest you the best move. Okay, so this is very difficult to program. In that situation, the best thing is to use reinforcement learning. Or we have a control problems like elevator scheduling. Excuse me. It is is not obvious what strategy would provide the best. The most training elevator services. For control problems such as this, the RL agents can be left to learn in simulated environment, and eventually they will come up with good controlling policies. So suppose that you have to program an elevator. What you do is, you just keep two feedback buttons. So if user presses, okay, and the elevator comes to it, opens the door, and then it just monitors the experience of the passenger it is carrying. Depending upon its feedback, the elevator's control mechanism, the policies will actually adopt, and that adaptation will grow on, keep on growing until it finds the best policy to be executed. Okay, so we can solve the elevator scheduling with the help of reinforcement learning. So in this picture you see that we have three types of learning: unsupervised, supervised and reinforcement learning. So if you take the reinforcement learning, so we can have real-time decisions, robot navigation, learning task, skill acquisition and game AI. So these are the application areas of reinforcement learning. And now if you take supervised learning, so we do two kinds of tasks. One is classification and one is regression. So if you see the regression, so what we can do with the regression, we can identify fraud detection, image classification, customer retention and diagnostics. So these tasks are basically classification tasks. And in the regression, population growth prediction, advertising popularity prediction, that some companies giving ads on the TV and newspaper, so giving that much amount of ads, how much sales they have generated. So it's a regression problem. So you can actually increase, if you want to increase the budget of advertisement, so before doing that increment in advertisement budget, you should know that how much target sale you can achieve. Weather forecasting, market forecasting, that is the stock market forecasting, and expected life, estimating the life expectancy. So these are all what? Regression problems. So these are the application areas of regression. Whereas in unsupervised learning, you can do clustering or you can do dimensionality reduction. Okay. So segmentation, customer segmentation, targeted marketing or recommended system. In the dimensionality reduction, big data visualization, you can visualize the large set of data, meaningful compression, structure discovery and feature elicitation. What features are required. So this is what a brief summary of application.